Alrighty, folks. How's it going? YouTube has got some issues. I think we are going to begin seeing the start of the media blackout. Don't know what's going on, but it's not my end. Anyways, what we're going to do is I'm going to run you through what I've been doing for the past couple of days. I'm sorry I couldn't live stream this. It's very unfortunate. I may light up the Rumble account. I might live stream to Rumble. I'm serious. I'm thinking about doing that. So, anyways, what I've been doing the past couple of days is I've been doing a lot of antenna maintenance, and I've done some analysis work. And I have some interesting findings. So the first thing I'm going to show you is the 40-meter array. And actually, it's not the first thing I'm going to show you. I'm going to show you something else. You guys are not going to believe this. Actually, I don't believe it. Let me get over here to this screen. And I'll show you. Remember, I worked the UBA contest a little bit ago. Check this out, man. I worked this event maybe 2 or 3 hours. That's it. And I keep telling everyone this. You do not need to work like a fool on these events to do really well. Check this out. Now, there's no trophy. There's no award for second place. Remember that. But this is a testament to my lack of drive. It's a statement. You do not have to be an incredibly driven person to make stuff happen. All right? You just got to get in there and just work a little bit. But it is a testament to the antenna systems I run. This is another one. So let me get over. I couldn't believe it. Here you go. UBA DX contest. I placed 72 worldwide. Is that special? To me, it is. I took second place North American continent, number 2 in the entire North American continent, place 2 in the continental United States. That's flippin' freaking cool, ain't it? Anyways, I figured I'd use that as like a precursor, a segue into what I'm going to show you. So take it for what it's worth. I laugh when I see stuff, when I get stuff like this. I'm like, I don't even put any effort into this crap. Which tells me it's not me. Maybe it has to do with the antennas. I don't know. So let me show you this first. Hang on. Get over here. I'm going to go ahead and light this up. We got the mute on, so.
And it's now finally it stopped raining, and I got to.
So I'll get over here.
Tilt over my shorter tower. It's a 40 foot.
See if I can get my audio somewhat balanced here.
It was one that was here already.
So what I'm going to show you is I did some work. Let me mute this really quick. I did some work to the 40-meter array. Now, those of you who have been with me for a while know that I will die with this antenna. I've told my wife, I said, when I croak, before you put the last nail, before you put any nails in the coffin, go out and cut the cord on this antenna, coil it up, and put it in the box with me. Bury it with me. I'm going to take it wherever I want to, wherever I'm going, you know? So it's kind of a morbid and kind of a ridiculous statement. But, yeah, man. Did some work to this antenna. This is the 40-meter parasitic delta loop array. Now, this thing was foobarred, man. It was a mess. I had 6 feet longer. Of course, a delta loop, they're supposed to be equilateral triangles. Well, they were not. I had 3 feet too less on one side of one of the elements. I had 6 feet too much on one side. I mean, it was a mess. So I went through and I remeasured everything. It's cut bang on. And by God, dude, I think what happened was the insulator slipped on the top. It's been up for 5 years. And with the wind thrashing it and everything has gone all out of whack and out of adjustment. And I've been wanting to do this for a couple years. So I just did it. I finished it up yesterday. It's taken me 2 days to get this one antenna sorted completely. Replaced all the feed lines, thoroughly cleaned the relay. The relay was all messed up. It was all corroded. So a little bit of 400 grit, I think it's 400 or 600 grit sandpaper. Freaking wailed on it, man. I couldn't get the connections. Connections were all messed up. It basically was a pin or a shield was lifting on the double pole, double throw relay. It wasn't making connection. So I'd flip it and go southwest and the whole thing would just fall apart, you know. Receive would just go to zero. Well, it wasn't zero. I could still see signals, but it wouldn't even load, you know. I knew something was wrong. So anyways, we'll give it a listen. We'll check the front to back on this. So what I want you to watch for is through this area right here, this 200. This is the AM broadcast band. All right. This is the AM broadcast section. You can see, and I'm pointed southwest right now. You can see this one right up in here around 260 is creeping in my back door. I've got my front to back again. So let me just click on the audio here.
And what did you say over and over?
And this is something you want to watch. The S meter and then this section of the pan adapter. I'm going to go northeast towards Europe. Here we go. 3, 2, 1.
And we'll try to do the same thing down here in Arkansas. And look for you get
Okay, so he's down in Arkansas. I should see anywhere from 10 to 15 dB front to back. So he's about an S6, so I'm going back southwest.
once again 73 WX5J.
Yep, so he's about an S. So I'll flip it again. Again, watch these AM broadcast. Let's go down here and check this guy out. Okay, that's going towards Europe.
Friday evening, early Saturday morning. Probably on here. Calling the CQDX of maybe another friend of mine in
Okay, going southwest. Northeast.
Take care. Yeah,
Yeah, so he...
Julia, all the best. I know, it's amazing. Well, that's great. Well, I know you're used to it. You guys, with your...
that doesn't count. That's John VY2WW.
Anyways,
They came back and there's some noise on the band, but
Okay, he's stateside, and I'm going northeast, so I'm going to go southwest.
so. I'll talk to you later, Joe.
There you go, 15 over.
K2ZGW.
That's 15 to 20 dB peaking. Going northeast.
I'm over here.
Ready,
over
3,
by
2,
the,
1.
You know, between Cherry Hill and Philadelphia.
Going back southwest.
7-3, talk to you later. Good talking to you. Bye-bye. 7-3 from N2OFJ.
Yeah, if you were in Long Island, I wouldn't
Northeast.
be able to hear you at all.
Yep, so that's about 15 to 18 dB at times. Depends on where how the signal's coming into the array. So anyways, figured I'd just show you that quick. So let's get over to, I'm going to show you what I found. So I ran all three of these antennas, the 20 meter deltas, phased array, the 40 meter parasitic array, and the 80 meter delta through the VNA. Did a full calibration between each frequency spectrum that I was analyzing on the antennas. These are monobanders. So we'll start with the 40 meter one because that's where we're at right now. So let me get over to the screen. All righty. Swept from 7.1 megahertz to 7.2 megahertz, right? So we got a VSWR best probably around 1.3. I'm sorry, 7.3. Come on, 7.13 and change megahertz. Flat, Q factor, very good. Here's the gain structure on the antenna. You can see this, really nice. Here's what I always look for. Minus 36 to 37 dB on return loss. That is crack-a-lack, baby. That's why this antenna works so well. Incredibly well. And you'll see with the other antennas, they're not this good. I'm going to actually change the 20 meter phased array over to a parasitic style running open stubs. It's such a more effective way of creating a parasitic system. Okay, so this is basically a snapshot of what the antenna looks like. Still under a 3-to-1 across the entire band, but you'll see the Q is fairly high. It's pretty high. By the time it gets to, what is it? Let's see, this is 2.4 to 1. 2.14 to 1. We're at probably right here is about 2 to 1. So that's, let's see, here's 7.2. So 7.15. So there you go on that. And I wanted it really in the DX area. This is a little low for my liking, but I can live with that. Still up around like 7.14, we're at minus 25 dB return loss, which is very respectable. Even 20 dB, 7.15. Now, technically, I figure if I took 8 inches out of the wire, it would move this way a little bit. But I really like the way it loads now, so I'm not exactly sure what I'm going to do. I'm not sure. I may go up and I may drop it down again, and I figure 8 inches, which would put me at, started with 140 feet. It was way too low. I was down around 7 megahertz. Let's see, I took, let me think about this. 18 inches. I took 18 inches out of it and it moved it up to here. So another 8 inches or 6 inches. I'd probably go 6 inches, which would be equivalent to 2 feet. And that should move me right into here somewhere, which would be perfect. That's the kill box. That puts me right in the middle of the DX area on 40. So I don't know. That's what I'm planning on. All right. Moving on. We are going to get over to the 80 meter delta. Let's go to this is a single element delta loop. So we'll take a look at this one. Okay. This is roughly right where I want it. Pretty much right where I want it. It's a little bit low, but that's okay. It's a little bit disappointing in the DX window, but it's pretty respectable in the areas I normally work. Unfortunately, return loss on I'm working a lot in the 3615 realm, which is probably right about here. So we're about minus 15 dB on return loss. Q factor is very good at that area. Very respectable. Of course, you can see the VSWR. It's about a 1, what is that? Probably a 1.15 maybe, somewhere in there, 1.6, 1.7. At probably around 3,700, somewhere in there. 3750, 3625. Yeah, probably, a little bit lower than that. Probably 3685, maybe somewhere in there. Right here. I should have swept it with markers. So it would have given me swept it with a tighter sweep. But we have 400 kilohertz of bandwidth on phone on 80 meters here stateside. So I wanted to do a sweep from all the way from CW digital 3500 all the way to 4K. So that's where the sweep is. So, so that's what the 80 meter delta, that's a single element delta. Return loss, peak return loss. It's respectable. It's about 24 dB, minus 24 dB. That's good. I figure anywhere from 20 to 30 dB is respectable, but it ain't as good as the 40 meter array. All right, we're going to head over to the 20 meter. Let me see if I can find him here. 20 meter delta. 20 meter delta, and now this is a phased array. This is a little different. So let's take a look at this dog. This again is tuned a little bit low, but I wanted it in the extra class portion of the band. So SWR is very good. You can see down around 1.5. This is probably 1.5 right in here. So probably 1.5, between 1.5 and 1.6. It's best. Best return loss, superb on this as well. Between minus 30, almost minus 35 dB return loss. And that's roughly in the same area, right at the bottom. So still 20 dB, minus 20 dB return loss, up around 14.2. That's okay. It's a little low. I need to shift that just a hair. If I could shift that over towards 1.6 over in here, that would be great. Q factor, very good in the lower portion of the band. And then if you look at the gain chart in dB, minus 120. It also has a big dip at 14.29, pushing 14.3. So there you go. I figured I'd show you guys that, and I'll let you fester on that. You want to see actually what they look like as far as how they're analyzed. Maybe it'll help answer some questions. And maybe the reason why I did this is so if anybody were going to try these antennas, you can see, you can go back to this and say, okay, if you don't have a VNA and you're going to try one of these antennas, or you're going to do something similar to this, these particular antennas, now of course every installation is going to be different and it's going to look a little bit different. But if you were going to try it, this tells you a little bit about how these antennas behave, how effective they're going to be. This is the return loss is huge to me. That's the one thing I look at a lot. And I figure, if I showed you guys this, like you'll see you'll see some very crappy antennas, like inefficient antennas, and return loss will be up around like minus 5, minus 10. That's just an atrocity, man. Not a very good antenna. May look good on paper, may look good in a model, but when you spank it onto a VNA or some kind of advanced analyzer and you start looking at the return loss on it and the Q factor, I mean, and the gain characteristics of it. I don't pay too much attention to the SWR. This is what I pay attention to right here. This and this. This tells me everything I want to know about how the antennas are radiating. And that's why I showed you another certificate I've got. These antennas work, and I wanted to show you why they work. For this QTH, would they work in another QTH? I don't know. I couldn't answer that. These antennas are proprietary to this QTH. I use them for a very specific reason based upon where I am geographically and geologically. The geological formations around where I live are extremely severe. As you guys know, I'm in a very deep hole, and I'm flanked by 3,000 and 4,000 footers in a ditch that's literally less than a quarter mile wide, with NBIS skyrockets going up on my east and west side. That's why I use these antennas. So I wanted to be able to snort the maximum amount of firepower out I could. That's it, folks. We'll catch you later. I'm sorry I couldn't get the live stream going. Something wrong with YouTube. I'm doing everything right. I tried launching it several times and it said there was an error. Streaming wasn't available right now. So whatever. We'll catch you later. 7-3 gang. And have a great evening. I'm really bummed about the stream. I like streaming because I like the interaction with you guys. 7-3. We'll catch you later. This is K1GMM, the maniac in the hole, the hack in the shack. I'm going to go up and do dinner. I got my whiskey. I'm happy. See ya.